So in this video, we're going to talk about solving a quadratic equation using factoring, using its factors. There are many ways to solve a quadratic. Here are some of those. We've talked about graphing, so you just find the x-intercepts. Those are the solutions. We've talked about the square root method, which is just like getting x by itself, moving everything away from the x. But sometimes graphing is kind of annoying, and sometimes square root method doesn't work. For example, if I were trying to solve this quadratic with square root method, I would subtract 10 from both sides and get x squared plus 7x equals negative 10. But the problem with this is I can't get x by itself because there's two of them. And so there's a way to handle this that we'll talk about later, but for now, I can't do square root method here. I can't get x by itself. So we're going to have to use another method. So we're going to talk about factoring today. Factoring is actually a great way to figure out the solutions. I do want to remind you the solutions to a quadratic have lots of names. They're sometimes called the x-intercept or solution. Sometimes they're called roots because you take the square root. Sometimes they're called zeros because it's where it equals 0. So if you see any of those words, remember that means the solutions to the quadratic. There's usually two, sometimes one or even none. Go ahead and see if you can notice a pattern between these parabolas, these graphs, and their quadratic equations. So I've already factored these. They're in factored form. Do you notice any connection between this root, negative 2, this root, 3, and the factors? So you may notice the solution is just the opposite of the factor. Same thing here. If I have positive 3, I've got negative 3 as a factor. Negative 2 is a solution. Positive 2 is a factor. The same thing happens here. Negative 5 and 2 are the solutions, and then positive 5 and x minus 2 are the factors. Let's see if that holds up for a couple more. This one's got a negative in front, but it still has solutions of negative 3, which matches with this x plus 3, and positive 2, which matches with x minus 2. Same thing here, positive 2, negative 2, positive 6, negative 6, and that always is the case. Here's what's basically happening. Remember, we're trying to see where the equation spits out 0. What can I plug in that would give me a 0? So let me show you one of these. For example, if I put in 2 to this equation for both the x's, I would have 2 minus 2 and 2 minus 6. 2 minus 6 is negative 4, but 2 minus 2 is 0. And 0 times anything is just 0. The same thing would happen if I plugged in 6. 6 minus 6 would be 0, and 0 times this would also be 0. So here's basically what's happening, is we're taking these factors, setting them equal to 0, and solving. Like figuring out where does x minus 6 equal 0? And where does x minus 2 equal 0? And that happens when you just solve for x. So just add 6 to both sides, and x is 6. In this case, add 2 to both sides, and x is 2. You see how when you solve it, it kind of flips the sign? So like I started out with x minus 6, which is going to give me positive 6 when I solve it. I started out with x minus 2, which is going to give me positive 2 when I solve it. So here's basically the gist. If you want to solve a quadratic with factoring, first you have to factor it, and then you just set both factors equal to 0 and solve. Again, that's because if either of them ends up being 0, the entire thing will be 0. For example, if x plus 3 turns out to be 0, 0 times this would be 0. Or if x minus 1 turns out to be 0, 0 times this would be 0. So basically, just set them both equal to 0 and solve. Usually that's going to be just the opposite of whatever it is. This one will give me negative 3. This one will give me positive 1. and you can check and make sure it worked. If I put in -3 for both x's, does -3 plus 3 and -3 minus 1 give me 0? Well, this is -4, but -4 times 0, 0 times -4 is 0. So yeah, it worked. All right, so sometimes if you're just given a factored version, it's quite simple. You just set the factors equal to 0. However, if it's not factored for you, you'll need to factor it, and that's why we covered factoring before we got into this. If you need to go back and watch some of those factoring videos, might not be a bad idea if you're struggling with this. This quadratic has 3 terms, so to factor it, we'll use rainbow method. Multiply whatever number is in front, in this case just a 1, times whatever's in the back. 1 times 10 is 10. So I want to find 2 numbers that multiply together to give me the rainbow number, 10, and add together to give me this middle number, 7. So this one was the rainbow, this one was the middle number. Some things that multiply to give me 10 would be 1 and 10, 2 and 5, and that's it. 2 and 5 will also add to give me 7, so that's what I need, 2 and 5. And then you fill those numbers into your factors. So x plus 2 and x plus 5. And now we do what I said in the last slide, which is just set them both equal to 0, and that will get you your 2 solutions. So either x plus 2 equals 0 or x plus 5 equals 0. Just set this equal to 0 and this equal to 0. This one will give you -2, the opposite of this. This one will give you -5. There we go. There's my 2 solutions. You could plug them in here or even here and make sure it works. If I do -2 squared plus 7 times -2 plus 10, does that actually equal 0? It should. If I plug in -5 for both, it should work as well. You could also graph this thing here. Instead of 0, put it like a y or f of x and see if it works. So here's my graph, x squared plus 7x plus 10. You can see it hits at -2 and -5. So that's a way you can check your work too. All right, let's try this one. We've done this one quite a few times in other ways with graphing and with square root method, but you could also do it with factoring. This is 2 terms, and it's the difference of 2 perfect squares. So the way I'll factor this one is the square root of x squared is x, the square root of 4 is 2, and you make one plus, you make the other minus, doesn't matter which one, and that's pretty much it. Now we'll set the factors equal to 0. So either x plus 2 equals 0 or x minus 2 equals 0. This one's going to give me -2 as a solution. This one's going to give me +2 as a solution, which is what we got earlier when we tried these. You'll notice on the graph, if I graph this equation, it hits at -2 and +2. All right, on this one, it's actually not equal to 0. And so if I start trying to factor this thing, I don't have all the pieces that I need yet. Basically, I need everything over on the same side so that I can factor it. So all I have to do to get it all on the same side is just add 3 to both sides, which will move this over. Now I've got 3x squared plus 10x plus 3 equals, and over here I'm just left now with 0. All right, now we can factor. It's 3 terms, so I'll do rainbow method. 3 times 3 is 9, so I want 2 numbers that multiply to give me 9 and add to give me 10. And that would be 1 and 9, or 9 and 1. So I'll fill those into my factors, 1 and 9. Except for I'm not quite done. This one had a leading coefficient that was not a 1. So I need to divide or slide with that 3 there. So I'll either divide it, like this one divides in evenly. 9 divided by 3 is 3. This one does not divide in evenly, so we slide it over and get 3x plus 1. Alright, so those are my two factors, and it's still equal to 0. And so now I'll set the two factors equal to 0 and solve. So 3x minus 1 equals 0. Oh, sorry, plus 1. And then x plus 3 equals 0. This one's going to be a little different. Usually it's just the opposite of whatever you have here, but this one's going to take slightly more work. We'll subtract 1 from both sides and get 3x equals negative 1. Then we'll have to divide by 3. And so x on this one is actually negative 1/3, which kind of matches with this actually. On this one, we'll just subtract 3 and get negative 3. So those are my two solutions, negative 3 and negative 1/3. Again, you could see it on the graph. It heads at negative 3 and negative 1/3. All right, let's try another one. This one actually has a GCF, so before you go start trying to do other things, it's got a GCF. I'm aware we could do this one with square root method, but we could also do it with factoring. So it's got a GCF of 2, so I'll factor that out first. And if I divide those by 2, that leaves 4x squared minus 1. Okay. At this point, you can just leave the GCF in front if you really want to, or you could just divide both sides by 2 and just get rid of it completely. That's probably what I would recommend, is just divide it by 2, divide it by 2, and so now you just have 4x squared minus 1 equals, and 0 divided by 2 is still just 0. So basically you can just get rid of the GCF. All right. Now I can factor this using the difference of two squares. The square root of 4x squared is 2x. The square root of 1 is 1. Make 1 plus, make 1 minus, and now set both of these equal to 0 and solve. So 2x plus 1 equals 0, and 2x minus 1 equals 0. This right here will be minus 1, 2x equals minus 1, then divide by 2. So I get negative 1/2 on that one, and this one's going to be positive 1/2. All right, just by the way, if you'd left the GCF in front, it really wouldn't have mattered, because when I set all the factors equal to 0, I set this one equal to 0, this one equal to 0. If I try to set 2 equal to 0, does 2 equal 0? No. So we can just kind of, that's not going to give us a factor at all. So you don't have to worry about it. Let me show you this one graphed actually. See how it hits at negative 1/2 and positive 1/2? All right, I think this is the last one. This one also has a GCF, so we'll deal with that first. It's got a GCF of 3. You can actually even just deal with a GCF right off the bat. Just divide everything, including the other side, by 3. That cancels that 3, leaving just x squared. 6 over 3 is just negative 2x. That'll be negative 8, and 0 over 3 is still just 0. Again, if you want to factor out the 3 and leave it in the front, that's okay. It's still not going to give you a solution. Now I'm going to do rainbow method because it's 3 terms. 1 times negative 8 is just negative 8. So what multiplies to give you negative 8 and adds to give you negative 2? Our options would be 1 and 8 or 2 and 4. So 2 and 4 is what we need. One of those will have to be negative, the 4. So fill those into your factors. X plus 2 minus 4. And I don't need to divide or slide because it was just a 1 in front because we got rid of the 3, so don't worry about that. And now just set those both equal to 0 and solve. This one will give you negative 2, this one will give you positive 4. And again, if we look at the graph one last time, here's the graph at negative 2 and positive 4.